Hi, my name is Avril Salter and I'm a co-founder of Next Direction Technologies. I've been doing public speaking and technology training and technical writing for over 20 years, and I specialize in the telecommunications and IT industries. And I wanted to give you a sample of my webcast. So this is a short extract of a webcast that I did for one of my customers. So I talked a little bit about deployment. Let me go on and talk a little bit about coverage and capacity. Now, the first thing you want to think about is what type of plan am I actually developing? Typically, when we think of wireless, people naturally jump into the coverage kind of thing. I want to make sure I've got wireless in these areas. And when you start to plan out your coverage network, some of the things, and we touched on this earlier, some of the things you want to think about is, do I need coverage in lift wells? So for instance, if you're in a hospital kind of environment, you can have quite a hostile environment in the where you've got elevators because there's a large amount of metal. You're moving perhaps patients up and down, and again you've got metal carts and things like that. And it can actually be quite difficult to get coverage in these areas. And you can say, do I actually need coverage when people are moving between floors or not? What's my business case for that? Stairwells, where people often use stairwells just in emergency situations. People don't often move between floors using the stairs, and it might be particularly true in some countries. I'm British, and in England we have a lot of trade unions, and companies in England will actually discourage you from using the stairs because of some of the liability issues, and they'll actually say to you, no, we want you to use the elevators, and so coverage in stairwells is not so important. And so in stairwells, again, can be very hostile environments to try and get coverage in. The other thing you want to think about when you're thinking about coverage is, and I mentioned this before, if you're doing voice and I want to have continuous voice calls, you might want to have your cells with something like about 15 to 20% overlapping coverage. And so when you're doing your cell plan, you've really got to say, okay, what is my expectation? What kind of coverage do I really want to achieve? Because it's going to make a difference to how many access points you're going to deploy. The thing that sometimes often gets forgotten when people are deploying wireless networks is they've got to think about the capacity issues as well. And quite often people will deploy for coverage, and out on the edge of the cell, your data rate drops because you're using a lower level modulation and higher coding, so that your data rate out on the edge of the cell will drop. And so quite often if you're deploying, say, in a graphics environment or something like that, they might say, hey, we really need the higher data rates. And so what then is that you really need to do a capacity plan. And what you're looking for there is, and your network will actually deploy out, and you'll say, okay, in these areas I can get to the higher data rates, and in these areas I'm at the lower data rates. And so you have to start thinking about deploying from a capacity perspective. And again, your plan will be different. And a capacity plan, if you're looking for everybody to have the higher data rates, will result in you deploying more access points. And so again, two different plans, and quite often when you go into a planning tool, it'll actually ask you, are you trying to do coverage, are you trying to do capacity? And the models will actually be quite different, and the results will be different, so you have to think about that. The other area, of course, is the link plan. And this, for instance, if you were doing, let's say you were doing a mesh network and thinking about deploying in a city, doing a metropolitan network, but you're connecting your access points, you're forming a link between your access points and then backhauling that as well. So not the coverage out to the users, but the connectivity between your street lights. You'd be doing a link plan. If you wanted to connect two buildings and you just wanted to use Wi-Fi as an alternative to a cable between two buildings, you would do a link plan. And what you're looking at there is what's the connectivity and what is the data rate that you're able to achieve over that link. And so different types of plans, you've got to know what kind of plan you want, and then you'll choose the tool, etc., to provide you with that right results that you're looking for. So very important to understand that right up front. whenever you're using a planning tool, right, all of the models that I've ever worked on, and trust me, I've worked on a lot of them over the years, they all start from the free space model. And in fact, the free space model is a great thing to know and to do a quick calculation on, because if you're planning out a network, guaranteed it's going to be worse than the free space model. So if you just wanted a worst case scenario, you can use the free space model, and it's a fairly quick model. You can plug in the numbers and you know that your wireless connection is going to be worse than the free space model. But all the models are based on assuming that you can transmit over the air with no disruption to that signal. And so what you're looking at is, I'm transmitting with this power. I need to receive at least this power to be able to decode and demodulate my signal. And then you're basically saying, given that I'm transmitting at this frequency and this distance, what is my path loss? And that should then be a very simple calculation as to whether you can connect or not. And so the free space path model is literally dependent on your frequency and the distance that you're traveling. And here in a free space model, notice here you've got F for the frequency and D for the distance. And in front of the log here is 20. And if you remember back to school, if you remember back when you did early science, you used to say, oh, my energy dissipates at distance to the square. That's where that 20 log D comes from. And so in more difficult RF environments, what we do is we simply change, instead of having D to the square, we have D to the cube, D to the fourth, and that just changed that value in front of that 20 log D. That's all we do when we move into difficult RF environments. And so again, it's all based on this free space model, and we vary it. We vary the model as we go into more difficult and more complicated RF environments. One last thing to tell you when you're looking at the free space model and you're plugging in your factors in here, if you ever see the free space model with different values where it doesn't say 36.6, all that means is that the frequency may be in gigahertz or the distance might be in kilometers as opposed to megahertz or miles. You'll see different values. That's all it means. And so it's very important when you're using the free space model that you know what the values are that you're plugging in, that you plug in the frequency in megahertz and not gigahertz, because otherwise the values will go wrong. To show you how, just to put the calculations in here, if you're operating in the 2.4 gigahertz band, and let's say you have a distance of 0.05 miles, and again, most of us tend to think in feet rather than miles, but you can plug it in here and you can actually see what would be your loss, assuming completely free space and line of sight environments. And again, this is your worst case scenario. You know that your RF environment is going to be worse than this, right? I should say this is your best case scenario. So again, very important to understand the free space model, and any model that you'll be using, any modeling tool is based on this. And if you understand that, you can sort of work out whether the model that you're plugging your values into is actually giving you numbers that are actually realistic. So if you understand the underlying calculations, this can be really important too, because a lot of times I've seen people plug in numbers into models and they get these crazy results, and they don't, and if they understood the free space model, they'd know why they're so crazy.
I hope you will take a look at our website, www.nextdirectiontech.com, and if you have any questions or comments or would like to contact me, please do so at avril@nextdirectiontech.com. Thank you.